thanks for joining my talk. We're going to be talking about a few different concepts today, and how this won't be a talk on service mesh, although that is in the title per se. We'll use it as a case study or an example of how things like configuration as data, GitOps, and generally be looking at this through the lens of Kubernetes, although it's not tied strictly to Kubernetes, but how these things fit together when you get into a complex scenario. And so service mesh is the area in which I work, and we definitely run into complex scenarios working with our customers and the open source communities. And this talk really is a how did we solve some of the problems around automation and multi-cluster using things like configuration as data and GitOps. So my name is Christian. I'm the global field CTO at a company called Solo.io. And I work on modern API gateway technology based on Envoy proxy, if you've heard of that. Istio as a service mesh, if anyone's. How many, I'm just kind of curious, did the title with the word service mesh in it, did that spark some interest? Are there people who are familiar with Istio and service mesh generally? Handful? Okay. And so at Solo, that's what we work on. I just recently published my book, Istio in Action, with my co-author, Renor, and the foreword was actually written by Eric Brewer of CAP theorem fame. And we just published it with Manning 2-3 weeks ago. I was going to bring some printed copies, but I'm gonna get them on Amazon here pretty soon. I think they're going to start shipping next week. I put up a code there if you'd like to get a discounted copy. Or you go to the Solo website. I think we are trying to give them away for free. I think you kind of have to search for it. I'm going to talk with the marketing folks to get that. But just real quick, and a little bit of background, a little context of how and why I'm talking about this today. So at Solo, we work on technology related to people's modernization efforts, things like Envoy proxy, things like modern API gateways, service mesh, eBPF, GraphQL, some of these things, and they all kind of come together to try to, what we focus on is what are the problems that we're trying to solve, right? People want high availability for their applications. People want failover and consistent security policies and traffic control and that kind of stuff. And they don't really care what deployment platform they're using. As part of their modernization efforts, they're probably trying to use containers and Kubernetes, but they have to bring the rest of their deployments in VMs. And some teams are moving to a public cloud, and now how do they bridge the gap there? And there's different versions of things, old versions of operating systems, firewalls, all of this stuff. And at Solo, we take a very application-centric way to solve this problem, but not by telling the developers, go build all this stuff into your applications, but through the lens of what you might see in service mesh. And so we're kind of leaders in this space, in the open source communities. We work with a lot of very large scale deployments of this technology, and that's kind of the backdrop. That's why I'm bringing some of those experiences to this conference here. So configuration as data, GitOps, and how does all of this start to play, right? So let's talk about a few of the concepts that will be coming out here in the talk. The first is this idea of treating your configuration and how you do deployments, how you put applications where they need to go with all of the right pieces around it. I think Kelsey Hightower coined this term, configuration as data. You may have seen other, declarative configuration. And I'm just kind of curious, how many people at their organization are running workloads on Kubernetes? So those, the folks who are familiar with some of the Kubernetes resources, the Kubernetes resource model are probably exposed to this kind of approach already. But what we're doing with configuration as data is we're saying, instead of trying to procedurally go through and say, hey, move this thing here, move that thing here, scale that thing up here, over there. And if you're on this infrastructure, you have to do it this way. If you're doing that infrastructure, do it slightly differently. Can we build a contract between the systems to which we're deploying and the end users that expect the system to be doing something, and specify that intention declaratively? And in this example, we look at what we're doing in a Kubernetes deployment, which basically says, I want the system to give me, in this case, 3 replicas, because we specified 3 in that particular slot, in the replica slot, of a service that's packaged as a Docker container, whatever the name is. In this case, it's Envoy. And I'm going to apply this to my system. And I want the system then to go make this so. Right? Now, how and what are the details of all that stuff and how that happens? The tooling that generates this type of data, this type of configuration, doesn't need to know all of those details. All right, so we get a contract between the tooling, the automation, the CI/CD, and whatever approach that you want to take, and what the end system looks like. And then you could go back and verify if it's not in that state, you know exactly what you're intending. It's described right here in the config. You don't have to try to interpret it or verify it. It's clearly stated. So that's the point of the configuration as data. How many folks, I'm just kind of curious, are following a GitOps approach or workflow to automation and deploying their applications? Just a couple, few, starting to, yeah. And the idea with GitOps is, hey, we want to build our automation, and we want to enable, developers and maybe SRE teams and security teams and so on to manage the platform. But we want to drive all of this through a configuration management system like Git. And so when we make changes to the system, we want to document and audit and track and diff and understand how that works. With Git specifically, there are workflows for interacting with Git, as you know, as developers. Pull requests and the workflows that you can build around pull requests for developer code can also be used for operational configurations. And so now how we blend these things together is, we as operators, as developers, we're defining our configurations as data. We're checking that in to Git, and we are using some sort of controller to watch what's happening in Git, and then go put it and apply it to our system. So Argo CD is a popular tool for doing that. Weave Flux is also another popular tool for doing that. And basically, the workflows that happen through Git, once they get to a branch that is ready for deployment, these controllers then identify the changes that were made and then go apply them to the system. All right, now there's still one last piece to this puzzle. So we've defined the configuration declaratively, so we understand what the contract is, we understand what the intent is. We have a thing that's going to take that configuration and apply it to the system. Now, the last bit is, now what is the system going to do to make this the case? So this is where the idea of controllers come into the picture. In the Kubernetes example, where we showed the deployment descriptor, deployment config earlier, that said we wanted 3 replicas of a particular type of service packaged as a container. That config gets applied to the system, and then there's a controller that watches that config and watches for changes in that config. And that's what's responsible for making those invariants true. making the system in a consistent state with what the intention was of the end user. So one thing that we've come across is this idea, and it's valid, that we store the configuration and as much of the system state as we can into Git, and we apply our Git-based workflows, following some of the GitOps practices. And so if we end up trying to store the entire state of the system into Git, and our system goes down, ideally, we should be able to bring it back and reapply the last configurations. And anything that had been changed and so on, that's all still tracked and audited through Git. So we build up this level of resilience. But so if the entire state of the system through declarative configuration can be driven through Git and this automation technique, then at what level do we need to think about what that configuration as data looks like and what controllers we need to actually take the config and actually do stuff in the system? All right, so this topic comes up quite a bit. And I'll go into a specific detail, but there needs to be a balance or a point where we say this is what the configuration should be, and this is what the controller's responsibility is. Let me give you an example. So again, using Kubernetes, we specify deployment configuration, and the controller is watching for this configuration, and then it goes and makes it happen. But that's not really what happens. In Kubernetes, what really happens is there is a higher level descriptor, higher level configuration that you specify as YAML. I want 3 replicas, and I want you to use this service, and here's some other config where necessary. But then when you apply that, the controllers are actually saying, okay, I need to figure out how to make this happen. And then the controller then spins off other resources that individually go and account for example, replicas. There's a replica set resource that gets spun out, and there's a replica set controller that ends up watching for that. Now, this becomes very useful, especially when you're doing upgrades, so that you can have multiple replica sets at the same time as you're doing a rolling upgrade. But all of that stuff is sort of hidden behind this contract of what a deployment resource looks like. All right, so you have the higher level thing that specifies the intention of what you want the system to do, and then how the system actually goes and implements that. There's some lower level controllers and lower level resources that get applied there. So then when we say we want to store the entire state of our system in Git and use GitOps, which configurations are we storing? The higher level ones or the lower level ones? Right? Because it would be pretty absurd to say, if I have a service that's made up of, let's say, 5 replicas. In Kubernetes, that actually gets down to the level of 5 different pods in Kubernetes. It would be kind of silly to say, well, I'm just going to store the YAML files that represent each pod in Kubernetes. And then do that for all of the services so that you kind of get rid of even the higher level configs like deployments and services and so on. So that would be kind of verbose, error prone, and a bit absurd. Now the opposite direction, where you say, I don't care about all the lower level configs, I just care about one massive high level config. And all of the stuff that happens, all the magic that needs to happen, that will just be baked into some controller, right? So we create a config that says, what is this, a good state, right? I want to put my system into a good state, yes. And then something goes and makes that happen. That's not useful either. So what we really need to do is figure out how do we balance this idea of a proper contract or useful contract and expressing the intent of the system. And in Kubernetes, we saw that there is this idea of a higher level abstraction that is useful for end users. And then, the lower level abstractions that go and make this happen. So we need to find that same balance. Now, I'm going to use an example that comes up frequently for us, at Solo at least, when we're working with our customers and when we're doing any of the work in some of the open source communities, open source projects. This idea of deploying anything across multiple clusters, and in this example we'll use Istio, but anything across multiple clusters, things get a little more tricky. It's not as simple as saying, hey, put everything into Git and then use a controller to just go replicate that across all of the clusters. So let's take a little bit closer look at that. So for those of you that are familiar or not familiar, I'll still do just a very quick recap what Istio does, or what a service mesh does. It allows you to pull out some of the application networking concerns of an application, like things like client-side load balancing, or service discovery, or timeouts, or retries, distributed tracing, these types of things, and pulls them out into a separate component that can be run alongside an application on behalf of that application, so that you get consistent implementation of things like resilience, telemetry collection, security, traffic routing, and so on, regardless of how you've written the application, and what language you use, and what framework, and so on. So we deploy these little agents, or these little sidecar proxies next to the application instances, and then we have something, a control plane, that manages the config for those those proxies. Now, again, I keep stressing these are not unique to a service mesh or Istio, but we definitely run into these in this scenario. When we want to take and run a service mesh across multiple clusters, the first thing we find in reality is that the services in the clusters aren't exactly the same in every single cluster. All right, so they're not always exact replicas, these clusters. Now, sometimes they are, and that's good. That can be good, right? Because you can get the first steps toward high availability by having multiple clusters doing the same thing. Secondly, we run into these services, they don't live in exactly the same, like in one cluster that might be a service foo might be deployed into namespace A. In another cluster, a service foo might be deployed into a namespace B. So these are not, even though the services are the same in these clusters, they're deployed differently, right? And you might find that when you want to release a new version of a service, that you might do that not across all of the clusters at exactly the same time. You might do that in a one-off cluster, or some canary clusters. And when we do this, and the services that are communicating with each other need to somehow account for things like failover, things like security policies, and things like certain canary-based routing. This really complicates how you go about configuring a system like this. It's not just here's our config, blast it out to every single cluster, because these are not exactly the same, and there's context in each of these clusters and differences in these clusters that we have to account for. So here's an example, simplified example, of how we might run, in this case, a service mesh or Istio across multiple clusters, where we've scoped the configuration of a single mesh down to a single cluster, but we want traffic routing between the clusters. We want failover. We want high availability. We want consistent security and identity between the clusters. So something needs to configure the service mesh in each of these clusters to have some sort of federation that happens between the clusters and on behalf of these services that live in the cluster. And some of these clusters might live in different zones, different infrastructure boundaries. Maybe some are in a public cloud. Maybe some are on-prem. Maybe some are in VMs or some OpenShift or something. And so how we unify this and how we configure all this gets really, really messy. In Istio, for example, we do have a concept of these configuration resources. These they're higher level for Istio configuration resources. Things like virtual service, things like destination rule, sidecar, service entry. These are all Istio's part of Istio's API. Now they're higher level for Istio because Istio configures Envoy. Envoy is low level. But this API, what it does is it configures a control plane in a single cluster and the workloads in that single cluster. So what that means is across multiple clusters, we would need to create virtual services, destination rules, sidecar, service entry, all of these different resources for the specific services that live on that cluster. And like I said, these clusters won't be identical. So you can't just take a virtual service for service A and just blast it out. You have to keep in mind, well, does service A even live on this cluster? If service A is trying to talk to service B, and service B lives in cluster 2 but not cluster 3, configuration needs to account for that. So how do we fail over? It has to be through, the configuration has to know to fail over to cluster 2. Or what if it's a public cloud and you've deployed your applications into a public cloud and the services in the public cloud maybe are not allowed to talk back directly to the services on premises? So now there are directional failover policies, directional security policies and authorization type policies, directional traffic routing policies. We want to keep traffic as close to the services as possible and understand how best to fail over. And depending on what cluster you're in, what it means to fail over and what's best to fail over changes. All right, so you have across all of these deployment footprints, you have context that has to be taken into account into the configuration. Compliance and regulatory isn't just something you can just forget or will away. Those types of context come into the picture as well. And then it's not just right getting it good enough to get it right once. When things change, services are failing, you're making new deployments. All right, the whole point of microservices and modernization and moving faster is to be able to make changes quickly to your services. That also introduces sometimes things that don't work out too well. So there's constant churn and it's very dynamic. So keeping the policies in place and adhering to those policies, even though the system is constantly evolving and churning, again, that's a lot of overhead to keep in your head or to write as automation and so on. So the model that we looked at in the most simplistic and when we were describing some of the terms around GitOps was, all right, well, let's configure things in a way that specify the intention clearly. We definitely want to use Git as our workflow engine and source of truth. And then we need some level of controller that then goes and applies the changes to the system and keeps them consistent. Now, in the case of Istio, what that would look like is somebody somewhere needs to understand what the context is for cluster 1, how that differs and changes for cluster 2, all the way up to cluster 100 or more, and codify, put that somewhere. They have to write it themselves or keep it in their head or whatever it is. That has to exist. And so what we've been working on at Solo with our our users, is how do we come up with a nice balance between what's a high-level config, what's a high-level configuration, declarative configuration, and what the process looks like for, where the controllers live, what they're responsible for, and how do you make a multi-cluster system like this work and work correctly and consistently and verify it, right? And so we've created higher level configurations for describing this policy, describing this intent. And then the controllers that we've built will then go and put the correct resources onto the right clusters and then keep that up to date following a reconcile loop. So before I get into a quick demo of what that looks like, are there any questions? Yes, right here.
Something similar to this using the AWS without a service matter, but use Terraform. Is there a difference in the things that are being solved using that tool versus this as far as state resolving an enterprise level state for your services, the change control, all of those aspects?
So just to repeat the question, I think maybe for the video, but you're asking, how, if I boil it down, how does Terraform, which is used for infrastructure as code, how is that related to what we're discussing here? Is that right? And there is a close relationship there. And so things like Terraform or Ansible or some of these, they're often used to kind of stand up the foundational infrastructure, and then actually I'm kind of curious, how many people are using Terraform today? Oh, nice. How many people are using Terraform to deploy applications? So what we typically see is people using Terraform to stand up the infrastructure, but then when they deploy their applications and the configuration for those applications and where those applications need to live and where they need to go, that becomes a little bit more free for all. And so the premise of things like Terraform and if you're specifying those configurations in some sort of data format that then any tooling can generate and create and modify and change, then you're following closer down that path of configuration as data. But it's that area where we see, okay, they stood up the infrastructure. They've, I don't know, use case that comes to mind is they've used Terraform to stand up a bunch of GCP VMs and set up the network and all that stuff. And then when they start deploying their applications, I've seen people, they'll use something like Jenkins and put a bunch of Bash scripts and Python scripts and so on to, well, the application needs to go here. We got to copy this file here. We got to enable this key, vault and so on for credentials and all that stuff. And that's where things start to become, you start changing those things. It's very difficult to understand what the intent of, your deployment configuration looks like.
We do tend to use Jenkins with change you get to push those changes.
Yeah. Yeah, yeah. And are you writing a bunch of scripts and a bunch of stuff to facilitate that? Like calling APIs and that kind of stuff?
Yeah, we call some other tools for orchestration of the apps. And also we have probably Posta doesn't
Yeah.
structure. So it's there's not a lot of copy and paste.
Yeah. Yeah. What's interesting is, if you look at, I think AWS does that. I know Google Cloud does this, where you are deploying your applications and trying to follow this declarative configuration model. Not only can you deploy your applications, but you can create configs that go spin up, storage, spin up message queues, databases, access to databases, and this kind of stuff using this declarative model as well. Yep. Yep. Any other thoughts or questions? Nope. Okay. Let me show you a quick demo here. Now, what we're going to look at is a multi-cluster setup where we have, let me see if I can find, didn't really come up with a diagram for this, but maybe I have one off the cuff here. It looks something like this. All right, we have a couple clusters running our workloads. They're not going to be exact replicas of each other because there's going to be different workloads running in each of the clusters. We'll have a third cluster, which we're calling this the management plane cluster. This is where the higher level automation that I showed in this picture runs. This is where a set of controllers responsible for some of these higher level configurations will live and watch Git for changes, and then when changes come through, then create the lower level resources that need to be created and put them on the correct cluster. So it is implementing a type of federation, but in this case, it's not as interested in, because we're talking at the service mesh level, we're not interested in the federation of deployments per se, but it's the federation of policies that are enforced around how services communicate and talk with each other. So you can think things like traffic routing. Maybe we want a certain percentage of traffic to go to V2 of a service versus V1, or we want to implement something like rate limiting, or service A can or cannot talk to service B. And depending on where these services live, on what clusters, and the context in those specific scenarios, the controller knows what all of that is and where to place the right lower level configurations. So if we come over here, if we look at the application, this is just the regular book info demo from Istio. So if I refresh a few times, you can see that we, on the right-hand pane, we see sometimes under the book reviews section that I see some stars that shows me a rating, and sometimes it's just showing me no stars. All right, so we're kind of load balancing just for demo effect across multiple different versions here. Now, the policies that we have set up and put in place are not directly the Istio configurations. So if we come and look at one of these clusters, let's go here. Let's kubectl. Let's go get a virtual service on cluster 1. Can you all see my screen okay? Okay. Now, these are the lower level Istio configurations. I mean, if I take a look at one of them, you can see this is a virtual service, and it's attaching to gateways, all the Istio stuff, right? But at the high level, what I really cared about is I want to expose my service potentially across multiple clusters. So now how does that happen? And I want to enable global failover for these services across multiple clusters. All right, and so what I as an end user would go create then is if I look at the configuration, which is stored in Git, if I look at a policy like our virtual destination policy. So virtual destination means I want to create a set of applications that are all treated as the same app. They live on multiple clusters, might live in multiple namespaces, might even have slightly different labels in some cases. But I want them all to respond to some global host name. So, foo.solo.io or whatever. In this case, we're using productpage.global, but this host name could be anything. What we care about is this contract, this intention that I'm going to define a global service. Anyone in those clusters and in that mesh can talk to this global domain name and be routed correctly to the service, following some, in this case, we'll create a failover. I think it's this one that does failover based on locality, right? But we could do things like priority or other ways to define failover. Now, under the covers, what this goes and creates all of those Istio resources. This goes and creates things like, let's get the Istio service entry in cluster 1. In this case, there happened to be just one, but because we've created one virtual destination. But it'll go create the correct configs on the clusters where it makes sense. That's another thing. So if I have a service that doesn't ever talk to this global service, then don't put that configuration there. All right? If I have security boundaries that I need to respect, then don't just start placing configurations everywhere for everybody, making everything global. Let's keep things as tight as possible. But that is a function of what these controllers are doing, the management controllers are doing, so that under the covers, everything stays consistent, everything stays correct, using the lower level and control plane configurations. So I can do one quick thing. So if I want to enable something like rate limiting, and I'm rate limiting for a particular service for traffic coming into the cluster or traffic between the clusters, what does that end up looking like following this model? So the first thing that I'll notice is in my configuration, I have a rate limiting policy, right? And I will apply this policy to resources that have been labeled rate limited equal true, right? Now, I don't have anything rate limited yet. I'm going to set that up. So if we come over here, where are we going here? I think we want to get the product page rate limit. So I can call this a couple times. I see I'm still getting 200s, all good. No rate limiting happening. Now if I come back here and take a look at my closer look at I think it's this one, where we say we're going to watch for requests that come in with a certain header. And if we exceed a certain count, in this case more than one per minute, if you can see that down there at the bottom, then we want to invoke the rate limiting. Now getting this to work in Istio, like I said, there's a lot of low-level configs that need to happen here. But what we care about is expressing the rate limiting values. And across multiple clusters, given all their security context and all that stuff, let the controllers handle that. And so now let's apply a rate limiting config. Let's see. Oh, I'm not logged in. I think this is all right. I should be able to come in here and directly edit this in Git. Let's see. Right, it is true. And now let's commit these changes, cross our fingers, that looks okay. And now we'll go to our, so we committed it in Git. We took some shortcuts, right? We just did it right in the UI. Ideally, you'd have some kind of workflow here. But then we come over here, and then we refresh, and we see that our config on the clusters is different than what we have intended and is specified in Git. So let's go ahead and sync that down. In this case, we're using Argo. I'm a big fan of Flux, too. Just happens to be I'm using Argo in this demo. Cross fingers, get green. So this means this higher level resource specified at this level right here, has now been applied to the management controllers. Now the management controllers are going to go and look at, okay, what cluster has this service that needs to be rate limited? Oh, it's all of these or subset or whatever. Now let's apply it to the service. So now if I come back here and try call our rate limit service, we see that we have one that goes through, and I think we should see a rate limiting 429 here applied. But so we didn't mess around with all the low-level Istio resources. We didn't go to cluster 1 or cluster 2, and these clusters are slightly different. And so what we did is we used a higher level declarative resource, push the abstraction into the right areas, and then now we're able to successfully run a, potentially we have customers running a model like this, and our largest probably thousands of Kubernetes clusters. All right, so wrapping up here. Let me see, drive everything through GitOps. This stuff can get pretty complex pretty quickly as you go through different infrastructure boundaries, VMs, containers, on-prem, public cloud, different versions of Kubernetes, different versions of operating systems, DMZs, all this stuff gets pretty complicated. Drive as much of this policy as you can through declarative configuration. If you'd like to learn more, please stop by solo.io. Check out my book. If you contact me on Twitter, I'll try to set you up with a signed copy because I don't have the physical copies right now. And we do a lot of public, free workshops on these types of topics with certification options and so on. So that's really all I had, and I definitely want to appreciate every one of you for coming out, and happy to stay around for a few minutes for questions. Thanks. Anyone on anything? What I discussed or anything else? All right then. Here, I know some of you are taking pictures here. Let me leave up some of the links here. But thanks again.